Okay, so now that we're back, I said that I would talk about what's going on with this character that doesn't look like a character. Let's stop the debugging session. And okay, so I want to show you something that will hopefully help, and I will tie that into how that relates to an integer and a character being the same thing to a language like C or C++, or even maybe some of the more modern languages that are C-like. They have this quality, and it's because, like I had said a few minutes ago, you're talking about something that's closer to the uh, true nature of the machine itself. So when code is compiled and run on Windows, on Linux, on Mac, and it's C++, or even C, when you're talking about the difference between an integer and a character, this is a property that is very important, and it will explain why the employee name that's a character with a value of 20 ends up looking like something that's not printable. So I'm looking at a CMU handout for the ASCII table. So read about this using a wiki, or even if you go back to the website that I'm showing now, and what you see is we said decimal 20. Decimal 20, if you look at what the character value is, this is not something that's printable. So you end up with a symbol that looks like junk, for lack of a better word. And that's because you're talking about a decimal with a value that doesn't have a printable representation. Now, the system has a table someplace or some hard-coded something or other in a library in memory that tells it when you give it this number, you get something unprintable, because it doesn't have a lookup in a table that can give you something you're familiar with. That doesn't begin until you get to the printable characters, which I believe might start at decimal 32 and go all the way to decimal 126. So we can test that right now. And maybe it'll help you understand how you might want to write a simple program that would do something like this. So remember, we're talking about fundamental types. I'm not going to get rid of everything. I'll just I'll write something in our main that will let me basically print out the ASCII table. So, print ASCII. Well, printable ASCII. Sorry. Let's do that. So we have this thing called a loop, and I haven't talked about a loop yet. So if you don't know what this is, don't worry, we'll get to it. But just know that a loop is just like singing, bottles of beer on the wall. And normally you start from some high number and go all the way down to no bottles of beer on the wall are left, or the 12 days of Christmas, anything where you repeat yourself, but the thing you're talking about changes over time. Loops kind of work like that. Okay? So let's see. So if I have an integer and I want to say ASCII decimal, just to give it a name, and I set it to, let's see, if we want to set it to the printable range, I said 32, so I'm going to set it to 32, and then I'm going to say, okay, while this variable is less than, what did we say, 127? Yeah. So yeah, less than 127. We're going to increment this value. That's what this means, and we'll get to this too. So you can do this, or you can do this, and it's the same. So what are we going to do? We're gonna do a printout of the actual value, and then we're going to. So okay, we're going to do that, and then we're going to add a space, because so first we're going to do this, and then I'll maybe I'll improve it a little bit. But okay, so we're going to do the print, and then we're going to have a condition that says if ASCII decimal is less than, actually, what do I want to do here? I want to print the decimal, print the space, and I want to do that until, all right, well, maybe I'll do something that's called a modulus, and for mathematics, it just means take a remainder, and we'll see how this looks. It won't be perfect, but I'm going to try and insert a line break in a way that makes it nicer to look at instead of just printing it all in one go. So let's see, maybe mod, not 6, let's see, well, okay, maybe mod 7. Then we're going to print a new line. And that's what this end L is. It is the equivalent of remember we have our outstream, and then we have the end L is going to give you a new line. So let's see what this does. So I'm trying to recreate that ASCII chart and also show you a bit about how the integers can be printed like characters as long as they're in the right range in the ASCII chart. Or ASCII table, however you want to say it. So let's run the debugger. Okay. All right, so it did all numbers. But it did manage to kind of do what I wanted, where it broke it up a bit. All right, so let's see. We want to actually see the characters themselves, and because I have integers and I want characters, I need to, instead of trying to print the number, I'm going to print the character. I'm going to cast. Because remember I said that you can take a type and cast it with a parenthesis and the type you want to turn it into, and that should give you a character. So let's see what happens now. Okay, so if we debug this, we start to see characters. So the first value here would have been the, let's see, the decimal 32. And the decimal 32 is a space. So we see that we've got our space, we've got our exclamation point, we've got our double quote, we've got our hash. So we've gone from decimal 32, which gives you all of, from 32 to 127. And we didn't print del because del's not printable. And the reason that this works is, like I said, and we're gonna keep revisiting this, because as a system level, developer, or someone who's going to work with things that might be lower level than what you would normally see if you're talking about a web form for, a website like Amazon or Google or something like that, you're going to have to really get comfortable with the idea that you have you've got this dual representation in the computer, in the system that you're writing code for, that allows you to take decimals and convert them into characters simply by doing casts. So that's what we did here, and that's why when we had, let me see if I can stop the debugging and undo all of this with some clever Control-Z. So hopefully the buffer is large enough that I can go all the way. Okay, so let's see if I can, does that redo? No, but this does. Wait, was that undo or redo? Okay, so that's how we went from, oh yeah, and I did this. So that's why we had an employee name, that's a character, but we had an integer, and the cast happened implicitly, which means you didn't tell it to turn this integer into a character, but that's what happened. Okay, so that explained that mystery, and the purpose of this particular lecture was just to get us a bit more comfortable with the ideas that are going to keep coming up, which is you can turn integers into characters, you can turn characters into integers, and the reason that works, one of the reasons, is because the underlying programming language knows how to take bits in memory and convert them appropriately. And we'll keep revisiting that. But that's it for this particular lecture. If you like what you saw, if it's useful, don't forget to subscribe, hit the like button, maybe tell someone else that might be wanting to learn how to use C++, because we're going to start off pretty slow, starting with some basic concepts, but we're going to get advanced over time to the point where you'll be able to write your own command line apps, your own desktop apps using the Win32 API. I mean, that's where we're going, but we're just not there right now. So thanks for tuning in, and I'll see you guys next time.